In place QuickSort in Python. I had to implement the QuickSort algorithm for a homework in a language of my choice and I chose Python. During the lectures, we've been told that QuickSort is memory efficient because it works in place, i.e., it has no additional copies of parts of the input array for recursions. With this in mind, I tried to implement the QuickSort algorithm in Python, but shortly afterwards realized that in order to write an elegant piece of code I would have to pass parts of the array to the function itself while recursing. Since Python creates new lists each time I do this, I have tried using Python 3, because it supports the non-local keyword. The following is my commented code. Now, I'm not sure whether I did the job well or am I missing something. I have written a more Pythonic version of QuickSort, but that surely doesn't work in place because it keeps returning parts of the input array and concatenates them. My question is this the way of doing it in Python? I have searched both Google and so but haven't found a true in-place implementation of QuickSort, so I thought it'd be best to ask.
Sure, not the best way, plus this famous algorithm will have dozens of perfect implementations. This is mine, quite easy to understand. Okay, first a separate function for the partition subroutine. It takes the array, the start and end point of interest, and the index of pivot. This function should be clear. QuickSort then call the partition subroutine for the first time on the whole array, then call recursively itself to sort everything up to the pivot and everything after. Ask if you don't understand something.
I have started learning Python lately and the following is my attempt at implementing QuickSort using Python. Hope it is helpful. Feedback is welcome. Smile.
Here's another implementation.
An in-place implementation with pivot as the rightmost element. Explanation, partition. One dot taking pivot as end, rightmost element. 2 dot bring pivot to its right position in sorted order. 3 dot comparing element at begin with pivot element. Loop breaks when all elements are checked indicated by begin, overlapping, pivot. Begin equals pivot. If elementary begin. Elementary pivot. The element is greater than elementary pivot. It is at a wrong place. It has to come after pivot. Swap elements, pivot, and pivot 1, if pivot 1, not equal begin. Swap elements, pivot, and begin. Now the element at pivot is either in position, pivot 1, or at current, begin, position. Either way pivot has moved one place to the left. So decrement pivot by 1. Else? Element at begin is equals to pivot and to the left of pivot. So it is at an acceptable position. Increment begin to check for next element. Explanation, QuickSort. 1 dot choosing a pivot, placing it in correct position in array and getting its index using the method partition. 2 dot dividing array into left side and right side of pivot using begin, end and partition underscore index. 3 dot calling QuickSort on left and right side array of pivot.
Posible, le hace con 7 subs de mí.